Good morning, dear students. I am Dr. Srinivas Patni, Professor of Chemistry in St. Peter's Engineering College. So till now we have studied about the fuels and combustion. So in the fuels we have seen the all completely solid fuels, liquid fuels and gaseous fuel. So I will ask one question. These fuels are renewable or non-renewable sources? What does that? These all are non-renewable energy sources. So once we have used, that will not create again. So if you are continually using once a time, it will completely closed. We can't use. So what can we do? For further generation, the scientists are thinking and developing a new energy source. That is what? Solar system. The solar is complete. The sun is always there. So lot of power is there. So we can create the cells, mean the solar cells. Okay? So now I am going to discuss about the solar cell. What is the topic? Solar cell. So what is meant by solar cell? So we have to discuss the working of the principle, construction. Okay, so these two we will see this one. So what is meant by solar cell? Tell me the solar cell. A solar cell is defined as an electric device that convert light energy into electrical energy. The solar cell is the light energy to convert into electrical energy. The solar cell works not light energy to convert into electrical energy through photovoltaic effect. What is through photovoltaic effect? Photovoltaic effect. So that is the reason we can say PV cell, photovoltaic. So PV cell, solar cell is nothing but PV cell, photovoltaic cell, or just photovoltaic cell. We can say photovoltaic cell or solar cell. So what is the definition? It is a device that light energy convert into electrical energy through photovoltaic effects. That is the solar cell definition. A solar cell is a PN junction diode. Already we seen in the unit second the molecular orbital theory. Semiconductors, we have seen the semiconductor. P-type semiconductors and N-type semiconductors. Already we know that. So N-type semiconductors mean so the excess of electrons, and P-type semiconductors mean that holes creation, the holes deficient. Boron, silicon boron, we have seen silicon phosphorus. Okay, so just recollect that words. So in this the P-type and N-type both combined together means some junction, P-N junction diode. Solar cell is a P-N junction. What is solar cell? Is a P-N junction diode. Mean P-type semiconductor and N-type semiconductors. So one junction is there. This is called the junction. So the junction. So this is the P-type. This is the N-type. So between the one is there the junction. So we can say P-N junction. P-N junction. Solar cells are a form of photoelectric cells. Photoelectric cells defined as device whose electrical characteristics such as current, voltage, resistance vary when exposed to light. The photoelectrical cells, when exposed to light, it is the variation takes place. The current and voltage and resistance. So individual solar cells are, we have to prepare the individual solar cells. For example, this is the individual solar cells. one individual solar cell. The individual cells, number of individual cells. So number 1, 2, 3, 4. 1, 2, 3, 4. For example, individual cell. The individual solar cells can combine to form modulates. We have to combine it. So now how many? So individual 1, 2, 3, 4, 5, 6, 7, 8. 8 cells are there. 8 solar cells combined to form modules, commonly known as solar panels. So this is called what? Solar panel. So solar panel is nothing but what? The combination of solar cells, mean one or more combined together, so to form the solar panel. Solar panel is nothing but what? That combination of individual solar cells combined to form a modules, commonly known as solar panels. So we know the solar panels everywhere. In our college also solar panel is there, water heater. That UV, the bacteria kills, they are using solar panels. The common single junction silicon solar cell can produce maximum open circuit voltage approximately 0.5 to 0.6 voltage. 0.5 to 0.6 voltage. 0.5 to the single junction silicon solar. So PN junction, single junction create how much of voltage? That is approximately 0.5 to 0.6 volts. By itself is not much. But remember, these solar cells are tiny, small particles when combined into larger solar panels. Mean smaller solar, mean 0.5 every solar junctions. So create the panel, mean larger solar cells. When combined into a larger solar panels, considerable amount of renewable energy can be generated. So understand? So what is that? Once again, the smaller solar cells combine or modulate to form together. That is called the what? Solar panel. Each solar cells create 0.6 voltage. So we can combine together to create a larger amount of energy. Okay? So that is about the solar cells and construction of solar cells. How can you construct it? So can you look the one diagram? Just we can understand the how can you construct the solar panels. And here see, we know the N-type, P-type and PN junction. That is very important. So silicon, we are using silicon or germanium. That material characteristics we have to study later. But N-type mean N-type. N-type mean already I told you in the molecular chemistry. So silicon, we are using the semiconductor. In this phosphorus, excess of electrons we are using. Silicon, the impurity is what? P is the impurity inserted in the silicon molecule. That is N-type. P-type mean what? P-type mean silicon. The impurity is boron. We are used in the boron. So here deficiency, electron deficiency mean holes. Here the electrons, excess of electrons in N-type and in P-type, that is the holes creation takes place. Here in the panel, in the cell, so what we have to see that one diagram I will draw it. Here first of all, this is what? A layer, N-type layer. This is what the N-type layer, N-type. So in this, what is there? Electrons, excess of electrons are there. This is the N-type layer. In N-type layer, what is there? One N-type semiconductor prepared in the lab. So that one layer coating on a glass, so that is excess of electrons are present here. And same thing here, one p-type. This is a p-type layer. Here what happened in p-type layer? Here the creation of holes. Some holes are there here. Holes. The holes are created. Just before I told you, the p-type semiconductor mean the holes are present. That here between this n-type and p-type, the junction is here. This is the junction. So what is this junction? PN junction, or what is depletion zone? We can say depletion zone. Depletion zone or PN junction. PN. So N-type, P-type. This junction is the PN junction. Here what happened? That electron hole creation takes place. Here the electron hole creation takes place. Electron hole creation takes place. Here and one more, here in the bottom we can construct one electron hole recombination. Here electron hole mean this is the electron. So hole will come like this, and this is the electron. We can say here, write this one because this one. Electron flow. Electron flow the electron will come. Okay, electron flow. The flow of electrons from here. So here this is called what? Recombination. Recombination or back electrical content. We can say back electrical contact. This one is the front electrical contact. So now we have to keep in the light. So what happened? The light comes from where? This is the light. So light. So light, sunlight. Okay, this sun is. So from the sunlight, what will come? The photons. Photons are there. The photons absorbed by the depletion zone here. Depletion zone. So photons. So what happened here? I will tell you that in the construction. So what is that? One solar cell junction diode. That is what? PN junction. That is, we can say, depletion zone. So its construction is a little bit different from the conventional PN junction. Okay, a very thin layer of p-type semiconductor here, p-type semiconductor grown on relatively thick n-type semiconductor. So we then apply the few finer electrons on the top of the p-type semiconductor layer. On the top of the p-type semiconductor layer. These electrodes do not obstruct light to reach the p-type layer. So just below the p-type layer there is a B junction. Sorry, just below the n-type. This is the n-type junction. Just below the n-type semiconductor, just below the n-type semiconductor, there is a B depletion zone, or we can say PN junction. We also provide the current collecting electrode at the bottom of the n-type. So here at the n-type of the layer, we encapsulate the entire assembly by the one glass. We can use one glass panel, entire one glass panel. So now, so how it will work? This is the construction. So now working is important. So this is a construction, construction what you have taken, n-type, p-type, some electrodes below the n-type and back type, and all are we have connected here. So how the working takes place of the solar system, that is important. Please listen. When light reaches to the PN junction, when light reaches the PN junction, the light photon, the light containing the what? Photons, energy packets, energy photons. Einstein told what? The energy packets are called what? Photons. So photons can easily enter into the junction. Photons enter into the easily into the junction through a very thin p-type layer from p-type layer. That what the light energy in the form of photon supplies a sufficient energy to the junction to create several electron hole pairs, several electron pairs. When the light reaches to the p junction, the p-type semiconductor creates the several electron holes. Several electron hole pairs. The instant light breaks the thermal equilibrium condition of the junction, the free electrons in the depletion region can quickly come to the n-type side of the junction. So here what happens, these holes is quickly converted into the n-type zones. Here the holes are converted into to go to the what? N-type. When the light immediately they are converted into the n-type junctions, n-type side, n-type. The free electrons in the depletion zones, can quickly come to the n-type side of the junction. Similarly, the holes in the depletion can quickly come to the p-type side of the junction. So holes come to this one, electron, these are the electrons, these are the holes. So holes come to this side, p-types. When the light absorbed from the sun, the electrons come to the n-type side and holes come to the p-type side. So here also cannot further cross junction because of the barrier potential of the junction. So once enter into the center, they never come down. Here also never go up. So similarly, the newly created holes once come to the types p-type side cannot further cross the junction, became the same barrier potential of the junction. So here how can we say here that the p-type side of the junction, the PN junction will behave like a small battery. So this is act as what? Small battery. That is a small battery, because the electron flow from here to here, then here the hole is there. So the junction is act like a battery. The junction is act like a battery. So what is that? The p-type side of the junction, the PN junction will behave like a small battery. Mean a voltage is set up which is known as photovoltage. If we connect a small load across the junction, there will be a tiny current flowing through it. So this one. So we are collecting here this one. So one small tiny current flowing here. So we can use the power from here. Okay. So now what are the characteristics? What are the materials we have used? So what are the material used? We have to know the p-type n-type conductor. The material which is used for this purpose must have the band gap. The band gap is 1.5 volt of electron volt. The material, for example, silicon, gallium, arsenic, cadmium, copper, and selenium. So all our band gap must be 1.5 electron. So what are the criteria for the material to be used? The material criteria, we have to select the material. Almost it must have the band gap from 1 electron volt to 1.5 or 1.8 electron volt. It must. The band gap should be 1.5 to 1.8. It must have high optical absorption. So because the optical nature compulsory, absorption is must. Absorption the optical activity is more. It must have high electrical conductivity. So it should be high electrical conductivity. And the raw material must be available in abundance. Plenty of raw material should be available. So if plenty of amount is available, the cost will reduce. The cost of the material must be low, because abundance means plenty of material should be available. If it is not available, so the cost is increased. So the cost must be below, because everybody we can useful, otherwise it will be very cost. So what are the advantages? So advantages are more. There is no pollution associated with it. It must last for a long time, because the sun is there for a long time, then we can use. That is the reason it is a renewable. It's not a non-renewable. So no maintenance costs. Once you have to install it, there is no cost. So it's continually working. But what are the disadvantages of the solar cells? So it has a high cost of installation. Almost one house required 4 to 5 lakhs of money required for one refrigerator, TV, and 2 lights. So required for almost 3 to 4 lakhs rupees. So the little bit very cost. It will the high cost installation. Okay, and it has a low efficiency. Efficiency also less. During the cloud day, the energy cannot be produced. For example, the rainy season, the many clouds will come, so there's no production of the current. And also at night time, so in 24 hours, almost 12 hours night, 12 hours a day. So it's also not possible. Okay. So what are the uses of solar generation system? So it may be used to charge batteries. We can use the batteries, solar batteries. So charging, and used to light meters, and also the power calculators and the wrist watches. We can use the solar. Once we have to use in that one, so can be used in the to provide the electrical energies. And so this is about the uses and application and constructions and working we have discussed. Okay, finally, how can you conclude this one? The solar cells has some disadvantages associated it. Disadvantages there and advantages also. The disadvantages are expected to overcome in the future, because scientists every day we are thinking and overcome it. The technologies, advanced technologies come. The cost of the solar plates as well as the solar installation cost will reduce or will decrease down in the future, and that everybody can afford. But now we cannot afford. But in the future, that everybody can afford to install the system. Furthermore, the government is laying much emphasis on solar energy. So after some years, after many years later, we may expect that every household and also every electric system powered by solar or the renewable energy source we can use, everybody can use, no power cut, no high power, no low power. So everybody, every house containing the solar system, whenever the for 30,000, 40,000, it is enough. Once we are using just 50,000, everybody can take the solar system. But the now present cost is the 4 lakhs. 1, 2, 3, 4, 5. So the present cost. In the future, it will reduce just 50,000 or at least 1 lakh. 1 lakh or 1 lakh. If reduces this much, so every house will take, every house. But it should be that efficiency also increases. Okay, so this is about the solar system. Okay, thank you.